Okay, we're going to get started in about, actually, in a few seconds. So let's get settled down. And today's topic is about Iron Python and dynamic languages on .NET. My name is Mahesh Prakriya. Along with me are two co-speakers. We have Martin Mali, who's a developer who's written much of Iron Python and is now focused on what we call dynamic language runtime. And Michael Ford, who is writing a book currently on Iron Python and also has some really, really cool demos to show towards the end of the presentation. And most of our talk is actually going to be focused on Iron Python. But we'll talk a little bit about the larger dynamic languages ecosystem. What you should expect to get at the end of this talk is really how do you use Iron Python for use in client applications. Tomorrow at 3:45 p.m., I have a different talk, WEB305, on how do you use dynamic languages, Iron Python, and a little bit of Ruby in the context of both Silverlight and ASP.NET applications. This talk doesn't demo any of that, just so I have enough time for both. I just want to make sure that you're aware of that. We'll spend about the first 10 minutes talking about overall dynamic languages initiative, the background, the roadmap, where we're headed. I actually think it's quite exciting, and it's really a new journey that we have. And after that, we'll go to some simple, sort of fun usage demos, and then we'll go a little bit more complex in our rich client demos. And after that, I will get into some more interesting and experimental demos. I'll do a little bit of XNA, and I have a small little robot on the side here that I'll bring up. I'll cross my fingers. You never know when you sort of have this many moving parts if all things work, but I'll cross my fingers and we'll try it. And then from a real customer perspective, Michael Ford is going to come up here in a bit at the end, and we'll talk about resolver systems and their experience with Iron Python, and also talking about resolver itself, which is really, really cool. I'm excited by that. And then we'll quickly summarize with one slide, nothing major. So hopefully most of my talk, about 60 to 70% of my talk, is going to be just demos. Right in the beginning is about 10 to 15 minutes of slides, so just bear with me a little bit, just so I give you context, and we'll go from there. So is that what you expect to get? Seems fair? Yeah? Okay. So just so I know my audience, how many of you sort of have used Iron Python, or Python in general? Okay, a few of you, okay? That's good, actually. All right. Michael raised his hand, I think. And okay. Part of this talk is about the larger dynamic languages initiative. So how would you characterize a dynamic language? I saw somebody here with a Lisp shirt earlier, I think. If I can see you there. Ah, there you go. So that should be interesting. So how would you characterize a dynamic language? What is a dynamic language? Well, it turns out that really there isn't a formal definition for what a dynamic language is. And it has varied over time. If you talk to somebody in the 80s, if you looked at the literature, a dynamic language is something that actually had garbage collector associated with it. It really turned out to be the case, especially coming from Lisp and other things. And on and on and on. It had other properties, but people looked at it and said, oh, it must be dynamic language because it has GCable objects, okay? Well, that's not the case anymore, right, with runtimes and other things in there. So there really isn't a formal definition, but it turns out that most computer scientists, when they see a dynamic language, they know one. So there is consensus today on what languages you would characterize as static versus what languages you'd characterize as dynamic. So how would you differentiate between static versus dynamic languages? What is a static language? Yeah. So well, a static language is something whereby you have this notion where this object actually gets bound to a type right at compile time. And for most part, and most static languages, it's not really morphable at runtime. Okay? And that's unlike the case in dynamic languages, where you have basically the notion of a type being associated with an object happens at runtime, as opposed to there's no compilation step in any way, as opposed to at compile time per se. Okay? That's one differentiation, but there are many other differentiations as well. Typically, dynamic languages come with a REPL loop. In other words, read eval, print loop, much more interactive, um, immediate feedback style environments, as opposed to static languages, which is more of a compile debug cycle that you would go through, Visual Studio Project System or something else. And then some more higher end differences between static and dynamic languages, such as the notion of metaprogramming and the notion of object morphability and the notion of runtime reflection and runtime lookup. And those kinds of things are actually very, very powerful and very flexible ways in which you can use dynamic languages. One mistaken notion that I would like to correct is that most people tend to think of dynamic languages as, oh, it must be untyped. It must be the untyped language because they've been used to VB or historically in the early releases of VB or other languages out there. But it turns out that's not the case at all. It's a completely different dimension. So there's actually two dimensions. There's static versus dynamic languages. And then there's actually the notion of sort of like untyped versus strongly typed, or weakly typed versus strongly typed languages as a whole. Okay? So really, there's a two-dimensional axis that you can sort of plot these languages in. So how would you characterize C? It's definitely a static language. Would you consider it strongly typed or weakly typed? It's definitely weakly typed, right? You can just cast anything to void star. You can go party on memory. You can do anything you want to. And conversely, if you look at something like Python, it's actually strongly typed language as a whole. So that's basically my background on, since I have Iron Python on dynamic languages, I wanted to make sure that I cover this notion of dynamic languages. In the future, I will do like a chalk talk. It'll be fun to do why dynamic languages as a whole. This particular talk is not going to be about philosophy. It's more going to be about practically what you can do with it. So let's see what we can do with it. Okay. So before we get into Python, I want to cover the larger ecosystem that we're building. This is very, very important. I joined CLR back in '98 when we were starting to create this notion of a runtime that really most people didn't get. Why do you need this common language runtime? Why is it interesting? And I remember getting those questions many times in the company and outside when we have design previews and things like that. So it turns out that one of the biggest problems that you have is this notion of interoperability of libraries. This notion that if you had, like if you think back in the 90s, right, if you had MFC, and MFC was really great from C++, but if you really wanted to use it from VB or any other language, you're really stuck, more or less. And conversely, if you had some VB libraries, of course, C++ users tend to sort of hack on things, but similarly, you couldn't as easily use them because there isn't a common type system. There isn't a common lingua franca that allowed you to communicate among each other. And CLR came along and it provided several infrastructure elements that allowed you to get this interoperability and ecosystem of common libraries such that if you think of .NET Framework today, you think, oh, of course I can use it from any language. That's just a given. You don't even think twice about it. It doesn't matter what portions of .NET Framework are written in, and as long as they're CLS compliant and things like that, you just use them from any language that you care about. And that interoperability is provided today precisely because we have common language runtime. In a similar way, when we started doing Iron Python, after Iron Python 1.0, we started looking at the notion of dynamic language runtime and the need to create that sort of a level playing field and ecosystem and interoperability among languages. If you think about languages and their frameworks today, right? If you think about sort of a Python library or something else, or if you think about Perl today and CPAN and Common Perl Archive Network, it really is not usable from any other language in an easy way. And that sort of creates these islands where you might write some piece of code, some library that's not really usable as easily from other languages there. So we're starting to create this infrastructure that allows this ecosystem of languages to flourish. And in this release, in the first release, actually, we've released so far 3 languages on top of dynamic language runtime, also known as DLR. And those 3 languages are Iron Python, Iron Ruby, and JScript. So we released Iron Python and JScript as part of the mixed release in Silverlight. I'll cover these elements in Silverlight tomorrow, but it's just so you know. And VB is something that is, we're working hard in targeting that to DLR as well. And in addition, working with third-party languages for things like Lisp, for things like others, in getting an ecosystem going on top of DLR. We already have implementations of these on top of DLR as well. So okay, that's fine and dandy. So what do you get? You get much better interoperability. So you can actually share code among libraries. It doesn't matter what language you write in. In addition to that, what you get is a lot of things for free. You get this entire notion of Visual Studio ecosystem and Visual Studio ecosystem and the notion of tooling for free. If you use Python today in open source environment, how do you actually debug the program? How many of you use CPython or some other variant thereof? And how do you debug the program today? Use print statements, effectively, right? There isn't this ecosystem of mature tooling that's out there. And what we're bringing to all of the dynamic languages is Visual Studio integration in the long term that comes partly because of DLR and partly because VSIP and VSSDK system as a whole. In addition to that, because I'm focusing on client side today, you can use this entire stack in different environments. You can use that in Windows Forms, you can use that in WPF, you can use that in robotics, you can use that in XNA. In fact, robotics ships are in Python today, and there are many others that ship that as a whole. So this is the larger picture that I wanted to give you sort of a sneak peek at before I start delving into Python in particular. Fair? This particular talk is actually going to be about that one slice through this picture of Python running on top of DLR, running on top of CLR and the frameworks, using Windows Forms, a little bit of WPF, a little bit of robotics and others. Small samples to show you how you can use that. Fair? So actually, who uses Python, right? Why is Python even interesting? I've seen enough hands, about 30% of the people have already used Python, so I'm actually going to go through these slides in a quick way, just so I can get to some of the demos in there. So it turns out that there are many out there that use Python. I'm not going to read these codes line by line, but it's interesting to see that ILM and others today, Industrial Light and Magic, who actually do the graphics for Star Wars, use Python. They find it quite productive, quite interesting. There are pretty big names out there that have really benefited from the ease of use and from sort of pragmatic nature of Python as a whole. Okay? So another example is gaming. You would not think of gaming as a space where you would think of dynamic languages or scripting as a whole. But it turns out that there are many games out there in gaming environments where people do write portions of the code. You might write the core in C or C++ just to get the most performance out of it. But you would write some more extensibility in languages like Python and others. And similarly, Google's been pretty vocal about how they use Python pretty extensively. And Peter Norvig actually has said at PyCon that they're very heavy users of actually Python. And they're pretty supportive of that. And as you know, they've hired Guido since then, who's the inventor of the Python language as a whole. OK, that's fine and dandy. But what does Python provide me? You're thinking, OK, that's Python as a whole. That's great. But why is Python interesting? Python is interesting because of 4 factors. Okay? If there's one thing that you take away from this slide, it's really about 4 things. First of which is that it's a true implementation of Python as a language. It's a highly compatible implementation of Python as a language. Microsoft is now a member of Python Software Foundation and helps define the course of Python. And we are pretty active members and sponsors of PyCon. Last year, we sponsored PyCon as a whole. And actually, we were one of the sponsors of PyCon precisely. And we're very active in the community in hand-holding many users out there. And we're a pretty compatible implementation out there. So that's one. Second thing is that just stopping there won't help, because we believe that there's a richness to .NET libraries that we bring to Python that you do not have access to in other places. I'll do some interesting demos today that I challenge people to think about. How do you do this in open source environments? Because that's the richness of libraries. That's sort of making use of other people's work in .NET in a very easy and simple way. Okay, that's the second pillar of Python. The third aspect of Python is the fact that it's a completely open source project. How many of you know that, actually? Curious. Few of you, OK? All right, you guys are raising your hand. So Python is a completely open source project. In fact, our license about a couple of weeks ago has been approved by OSI. And we are releasing, you'll see an update under Microsoft Public License. Effectively, it's just a title change. It's an extremely liberal license, and it's open source as a whole that's available on codeplex.com. I'll show you that in a minute as well. And finally, the most interesting thing, one of the most interesting things about IronPython, which is sort of hard to demo, and I'll show you some slides in a bit, is the fact that it's actually one of the fastest implementations of Python out there. The reason it's called IronPython, how many of you have seen Iron Chef show, where it's a bunch of chefs on stage and whoever sort of comes out tasting best, right? So that's the Iron Chef, right? So in a similar way, IronPython is about the fact that it's one of the best implementations of Python out there. So those are the 4 pillars. Again, to summarize, it's true Python implementation, really seamless integration with .NET, built on top of DLR. In other words, it creates a level of ecosystem that otherwise is not possible. And it's open source. If you want to contribute down the road, feel free to contact us. And it's one of the fastest implementations of Python. OK, that's fine. Actually, before we get to Martin, I want to sort of show you a quick demo. OK, Start Python console. Yes, I know. I still have 101 here. This is my XP tablet that still has the old stuff on it. My team will actually give me a hard time there. I have other 2.0 versions on there. So we bring up all this DLR and ecosystem and everything else, and we always type 2 + 2. We're pretty superstitious. Nothing else goes right unless you get 2 + 2 right. True to 64. OK, great. This is the interactive interpreter that you got. And one of the interesting things is that, OK, why is it status compliant? So let me actually show you a quick demo and say, hello, Barcelona. OK? So many of you have used IronPython and Python as a whole. So what should happen if I hit return on the string right there? What should happen? Not too much. Right. So what happens is that when I type it in, most of you who have used .NET are used to sort of saying, yeah, string, to-lower method. It should make sense there. So what happens when I hit return is that it says, like, hey, the to-lower attribute doesn't exist on the string object. Really? How would you do this in Python? In standard Python, what you would do is actually you just say, just lower. Right? The reason is that at this point, there are absolutely no .NETisms. When IronPython starts up, there are really no .NETisms at all whatsoever. And we work hard to make sure there's a completely compatible implementation out there. But if I were to type in this one thing called import CLR, sort of which enables me to sort of import .NET into my environment, and now I hit return on to-lower, right? Automatically, all the .NETisms start coming into play, and then the things that you used to start working as a whole. Okay? So we're going to take about a 10-minute detour at this point, and I'm going to invite Martin onto the stage to demo to you, since ours is an open source project, and debug through what is happening underneath the covers, and sort of show you a little bit of what's happening underneath the covers there. Okay? Please welcome Martin. Thank you.
Thank you, Mahesh. What we're looking at up there is Visual Studio with a little bit of Python in it. Essentially, it's the demo that Mahesh just gave, except it's in text file as opposed to interactive console. It's going to make it easier to debug. The interesting line is the one with a breakpoint on it, the line 4. Unlike Mahesh, I'm using to upper, which makes very little difference. And if we just run this little code, it will do the operation twice. The first time, just simply calling to upper without any .NETisms. The second time, it will have imported systems, which is just like importing CLR. And the code will succeed, as you can see. So we always get the question, how does it work? How do you do that, especially with the DLR system running IronPython underneath? So let's look at it. We'll run it on the debugger this time. And voila, we hit the breakpoint. So you can see that I can hover over the M and see is the hello tech ed. that came from down there below. And if I hit F11, we step directly into the runtime. What we're looking at is the invocation of what we call dynamic site. I'll cover those more on Thursday. If we fast forward, what happens is that the runtime, the dynamic language runtime, will ask Python, how do you do this? The key is how do you do this, not do it. Because if Python gets the question, how do you do this, the runtime can learn and do it next time without help. So let's look at the call stack at this point when we hit the breakpoint. We just entered Python, but there is a transition. This is the last stack frame with runtime on it. You can see Microsoft scripting DLL. This is right before the runtime is asking the question. And this is the receiving end of the question. Python received the question which reads, let's look at the watches. The question reads, I need to get member to upper from whatever I gave you. And the whatever we got is a string. And then Python will go through some motions and try to determine the answer. Now, all the questions that runtime asks come through this place. So there is some routing mechanism to direct the right questions to the right pieces of code. So we'll skip through that. That's the stack frame right here. And come back directly to the piece of code that answers questions, how do you get member with a given name on a given object? We're now at line 48. And another line that is very interesting is line 50. If you look at them and compare them, they're very subtly different. Essentially, it's these three letters that make the whole difference. We'll try twice to look at the Python representation of string. What Python did when it saw a string for the first time, it looked around and found the two upper, the .NET version of it, stashed it away. It also added the lowercase upper on it, stashed it away. And now it's going to be looking into this world of names, looking for the two upper .NET version of it. The first time, it looks through the spyglass of I'm only pure Python. Of course, if I step over it, we don't get the answer. We didn't find it because it's not there. We are looking through the spyglass of pure Python. We didn't see to upper the .NET version. Second attempt will succeed because we're looking through the spyglass of, hey, I'm looking as a .NET guy. So we did find it. Now we'll fast forward through a little more guts of Python, Iron Python, where we're constructing the response. By this time, we've already created part of the answer, and we're right about to finalize it. So if I go back to watch, we can look at the pseudocode that Python generated. This pseudocode looks kind of like C#. If you saw IL-DASM or Reflector, this is kind of the mix of all of those ideas. Essentially, the way you can read it, this is what Python does when you're getting attribute from an object. We can call it even magic. We call some helper that is called Python ops make bound built-in function. The two upper turns out to be called in the runtime of Python built-in function. And we pass it the argument 0, which is the hello tech-ed string, to bind the two together. Those who use Python on a regular basis know that attribute access and a function call are separate operators for Python. So now we're just dealing with the dot with the attribute access. So this is the answer should things succeed. But because we were looking through two different spyglasses and saw two different views, we need to also modify the code to give the right answer for the two different approaches. So we will wrap the body. So here's the body. We will wrap it with a conditional statement. And the way it's modified now is the whole magic. This is the code that Python is giving back to the runtime as the answer to the question, How do you do this? How do you do get member of toUpper on a string? So first, if it's supposed to be visible in the given context, do it. Do the operation as Python would do it. Otherwise, simply throw what Michael said earlier correctly, attribute error. This str here is the name of the type. Python calls string type str. And as you can see here is the toUpper. Essentially what this means is throw I cannot find toUpper on a string. So again, if I rerun this code again, if I just continue the debugging, we'd be hitting these breakpoints over and over again because the questions come quite frequently and many of them. So the first time we come around, we hit the if and go to the second branch where we throw the error. In the meantime, we imported system, which changes the context to see the .NETisms. And when we come back for the second try, we find the thing. We come through the first branch of the if on the runtime side. There was no question that Python was asked in the meantime about the things because the whole answer was formulated at once. And this is it. This is the whole magic, how we do it. If you want to see more of this, come Thursday. Back to Mahesh. Thank you.
Okay, so like I've said, we've taken about a 400-level detour in for 5 minutes by design, and actually, let me go back to my slide on that. And as Martin said, he's actually doing a pretty technical. He's doing a pretty technical 400-level talk on DLR and DLR internals on Thursday in room 121 that talks about what is DLR and how do you target languages to DLR, and even has an implementation of a fun language, just from scratch, fun language on top of DLR in room 121. So I strongly recommend attending that. Just to summarize, so for those who haven't sort of tracked all of this, which is fine by the way, is if you think about CLR, right? So the lingua franca of CLR is IL, right? In a similar way, the way you speak to DLR is actually through ASTs, and in the form that DLR expects it to be the case. So with DLR, what we have done, I'm actually going to go back a few slides because it's actually worth covering really briefly. Hello? Okay, so what DLR does is lower the bar for language implementation such that you don't even have to sort of do all the hard work of getting to the point of emitting IL. All you need to do is hand us a tree in the form that we require, and Martin will cover all the details on Thursday, and we will do the rest of it for you, which is a very, very powerful way to sort of take advantage of the back end and language implementations there. Okay? So we covered the first bullet so far, which is about, hey, is it a true Python implementation? There's a ton more details and exception handling and others that one could do a bunch of demos there. I'm not going to do that. From now on, I'm just going to do how you can use Python, IronPython, on top of .NET as a whole. So let me see if I can just break away, do some demos, and then go from there. Okay? Okay, that's fine and dandy. But so what I'm going to do is, at this point, I'm just going to do a dir, right? So Python is such a dynamic language. It shows you at the top level what modules you have available. So I'm going to go ahead and say import MS agent. Some of you might have seen this already. And what I'm going to do is, the first I'm going to load up a COM object, MS agent object that's on my machine, go poke at it and talk to it. Okay? So what I'm going to do is say, actually, let's just do a dir on MS agent to see what's available there. There's a bunch of things available, but it looks like there's this load character method. So okay, I'm going to go ahead and load up the Merlin character. Okay, right there, there's Merlin. We like Merlin because that's what our team is named after. It's the magic of programming on that, right? So let me see if I can size. Ah, there he is. Okay. So this entire notion of sort of being able to go talk to a COM object, bring it up, just poke at it, right, and play with it, and just any object on the machine is a pretty powerful thing. So there's this entire thinking and this argument about this kids programming language, and my argument is that there's no such thing as a kids programming language. You should just be able to sort of have a simple enough language that sort of spans the entire spectrum. So what I'm going to do next is, really quickly, have Merlin wave to you guys. They're right there. Wave, Merlin, wave. Right there, okay? So I can have Merlin think and say, hello there. Whoops, okay? I can have him think about it. And then, so I can actually have Merlin dance around and say, move to, I don't know. I have no clue what these coordinates do, but right there. Okay, well, looks like he's going to go sit on my console. So I'm going to move him away. And so the interesting part is that you can actually go ahead and poke around and say, look at all the animations that you get, and just print them out to the screen. Can everybody see this okay? Yeah. So Merlin can do a lot of things. So instead of printing them out to the screen, what I want to be able to do is actually take these methods and just stuff them into my globals, such that I can actually just call them directly without having to sort of go do this dispatches. So what I'm going to do is globals fucking type globals, and okay, so what I've just done is, if I look at my globals right now in Python, a bunch of methods at the top level that Merlin can do into my environment. I'm just going to print them out. And you can make Merlin do, like, if you didn't get it, you probably are confused by now, so Merlin looks confused. Or you can actually have him congratulate, right? And say, hey, all right, so the demo's going okay so far. And you can have Merlin say, hey, we're here to sort of announce this DLR and this entire ecosystem. And you can just go ahead and just sort of play with it. You don't need this entire sort of Visual Studio environment, project system, file new project, create something, add references, compile, debug cycle. Just get up, load up an object, poke at it, call methods on it, and interactively play with it. And that iterative notion is actually very powerful. And there's actually many kids that sort of love playing with that sort of an environment there. So what I'm going to do is I'm actually going to stop. Sometimes people get annoyed with these kinds of demos. So I'll go ahead and I'll just go ahead and have Merlin go away. So the first demo, what I've shown you is this notion of just loading up MS Agent, looking at the methods on there, importing them into my global environment, stuffing them into my globals, just calling them directly in a very dynamic and interactive way. And that's actually quite fun. So in the second demo, what I'm going to show you is a really quick WinForms app that you create. So what I'm going to do is I have a helper that allows me to go ahead and import a bunch of stuff, and so that I don't have to type all this in front of you there. So it imported a bunch of WinForms into that. So I'll go ahead and create a form. Okay, so I have a little WinForm right here. Great. Well, of course, this app does nothing. And I have this fancy tablet PC, right? And what I really want to be able to do is I want to be able to sort of go ahead and take my pen and be able to sort of write on it, right? So what do you think it would take to add inkability or the ink ability to an app in a quick way? What would it take, right? So it turns out that there is a .NET library, Microsoft.ink.dll, that's provided for you as part of tablet, or if you're running Vista, especially on the high-end versions of Vista, Microsoft.ink actually ships as part of Vista, so you can have external digitizers as well. I'll go ahead and import a bunch of top-level namespaces into my environment right there. So I've added a reference to this .NET library, Microsoft.ink, and from that library, I imported directly into my top-level namespace a bunch of objects, and I'll do an ink collector object, and then I'm passing a handle to the form right there. If I can type. Okay, so what I've just done about 3-4 lines of code is be able to go ahead and ink on my thing. So I'm just going to go right on it. Okay, so I'm going to cross my fingers now, right? So that's cool. It's not cool yet. Hang on, hang on, hang on, hang on. It's only cool if you can actually do something with the ink, right? Otherwise, it's just a bunch of ink. You can draw on any surface on that. So I want to go ahead and sort of poke at it, right? And say, I can just go all tab through it, but I want to look at on the ink collector object that is on my form. I want to look at all the strokes. And using the default recognizer that's available, and this is when I cross my fingers, okay? I want to say convert these strokes to some characters that I can actually use, okay? Right there. I'm going to cross my, right there, okay? So think about what happened, right? You wrote very little code. You wrote very little code. Handwriting record is a non-trivial problem. By the way, it's not just English. Nowadays, there's even a Catalan recognizer available to you. I don't know Catalan, so I can't write it. But so there's several recognizers available across the globe in terms of like Japanese, German, Spanish, English, clearly, and then of course Chinese, simplified in traditional Chinese, and of course recently Catalan as well. That was actually demoed, I believe, at the last TechEd, but it's not released yet. It will be released pretty soon. Okay, that's fine and dandy. Okay, I've done this. But what I really want to be able to do is write something on my screen, right? And this .NET thing is so powerful, you told me. I want to go make it speak. How do I do that? You get the pattern by now. Yeah, there you go. So what do I do? So it turns out .NET ships system.speech, okay? So what I'm going to do is a very similar pattern, right? Add a reference to system.speech, that's part of .NET. So if I can type, okay? So I added a reference to system.speech and imported a bunch of stuff into my top level namespace. Of course, some of the Pythonists will yell at me for doing a from foo import star, but I don't care. This is demos. But all right, so what do I do next? Well, I'll go ahead and create a speech synthesizer. Okay? And what I'm going to do is I'm just going to pass in this thing right here.
Iron Python rocks.
It really does, actually. So think about it. In about 10 lines of code or less, you've been able to convert handwriting to speech. And you might think, okay, this is just fun and games. What is the real use app? It turns out that the tablet team for this disabled person who could actually only use one hand has, because of stroke, and has gotten him set up. He lost speech, and he's gotten him set up with the tablet environment by writing a really quick app that enables him to actually quickly write and convert and speak in a pretty interactive way. And so there's many interesting applications that you can do in a really, really rich way. And the other thing that I challenge my open source friends to do is that, hey, try to find me something like this in terms of .NET libraries that I can use to go do stuff. In about 10 lines of, dozen lines of code, I've glued together interesting elements of .NET, right? That's all I've done. I've just written a little bit of Python code to glue together interesting elements of .NET and provided rich application for you, because much of the code is not mine. Much of the code that's being leveraged is .NET that's written underneath the covers, whether it's system.speech or whether it's ink or whether it's something else. That to me is sort of like the second bullet that I have here when I say, let me come back and I'll do some more demos. So when I say seamless integration with .NET, that's really what I mean, is that not only can you sort of go poke at COM objects that are on your machine, MS Agent, all the things, you can actually go ahead and sort of import any interesting or sometimes exotic libraries, whether it's Windows Forms or others, and sort of be able to sort of create rich applications in a seamless way by just gluing together some stuff. That to me is quite fun. I mean, that's actually making programming fun. And when we started our group, it's actually one of the mantras that we had is, hey, how can we make programming fun as opposed to a chore at the end of the day? So let me see if I can do a few more demos, and then I'll sort of come back to my slides in a bit, because slides are oftentimes boring. And we'll go do that. Okay, so where am I? So the next thing that I want to be able to do is I want to sort of create a WPF app. Of course, it's not interesting or sexy nowadays unless you do something WPF, right? And it's got to be XAML and XAML based. And I'm not a designer, so you're going to see some wacky small demos as a whole. So again, I have a helper that says a bunch of WPF classes into my, as you can see, it takes a second to load up all the WPF into my environment right there. And I want to go ahead and sort of create a window. Okay. Again, I have a quick little window right here that's a WPF window that effectively does nothing. Okay, great. I have a WPF app. So what I want to do next is actually just want to load up some XAML that I have that I've generated in a designer such as Blend, right? So I'm going to just say okay, and then I want to set the content. This is a really old tablet, so things actually take. I'm still running XP on this, by the way, because I just didn't want to upgrade it, but I'm going to upgrade to my new machine. The speech on Vista is incredibly realistic. So if you haven't checked out system.speech, if I do the same demo, like at least for the speaking part on my regular laptop, it's incredibly realistic. Both Reco and synthesis are really, really good, so I recommend checking that out. I'm detouring. Anyway, so I want to set the content of my little app and say I just painted something up in XAML, and right it is, okay? But of course, this app does nothing. I can't do anything on here yet, right? So what I want to do next is I want to sort of use this feature called list comprehensions in Python, and grab. I'm going to walking through the entire calculator tree, right, and say is instance if it's instance of a button class, right? Go ahead and grab it and let's put them in there. So this little feature here where you sort of have this expression in this little brackets and say, give me a list. It's pretty powerful actually. It's list comprehensions that allows you, before I lose it, the underscore means the last reference thing in Python, so I'm just going to set it to a variable so that I actually have a handle to it. So what it did is earlier, let me actually show you, is that it walked through the calculator tree and looked to see if that element is of a button and created a list for me in one line of code using list comprehension in an interesting way. And these are the kinds of things in Python that you can do that you cannot in other languages, such as C#, for example, on it. So what I'm going to do next is I'm actually going to go ahead and sort of play with this. So the in buttons, right? And my tab completion sometimes works, sometimes doesn't. Okay, so I want to set all the font sizes to be double the size because as it is, you can barely see that thing. And right there, okay, great. Now I can just go ahead and sort of interactively play with this environment right here and say foreground equals I don't know, orange or something. I told you I'm not a designer, right? So you can interactively play with it. Okay, maybe it's not quite orange. I'll just go and say old lace. I have no clue what old lace is. Oh, well, you can't see it. Atlas blue, all right. We'll do aqua white. No. This is what happens when I'm trying to like red. There you go, that you can see. That's a color that I know. I told you I'm not a designer, okay? So you can interactively play with this. Of course, it's not really a WPF app if you don't actually go ahead and say, I want to go ahead and do interesting stuff with it that I cannot do in WinForms app. So I'm going to go ahead and sort of rotate all my buttons 30 degrees, right? Because it can be done in WPF. Therefore, I will do it. So and then you can actually go ahead and sort of play with this a little bit more. But of course, it's not really a functional calculator, and that's not the point, right? We're just having fun so far. So let me just create a quick method, okay? And So what I'm going to do is I'm going to create a really quick method that takes the button and the event args and says do something with the button name right there. And then, so, okay. So I tied it to that. So now if I were to click on it,
2 plus 2 equals
it's clearly still not functional. I'm going to go ahead and sort of import a, okay. So I'm going to go ahead and import calculator right there. So all it is just a helper thing that sort of registers a bunch of event handlers on the buttons, right? And then, so if I actually click 2, you'll see 2 there.
plus 2 equals
Of course, it didn't say the last part. I could tie that up as well, right? So that's my quick little WPF demo. Not the greatest WPF demo, but it's actually fun to sort of interactively just start something up from scratch and play with that as a whole. So these are the kinds of sort of interesting small things you can do, but towards the end, we'll show you some realistic customer examples of the kind of stuff that you can do as well. So let me come back to slides for another about 5-10 minutes, and then I will go do some more demos in a bit. Okay. So actually, let me show you the open source aspect as well. So one thing I talked about is the fact that we're fully open source, and you can actually get at it from codeplex.com/ironpython, where we publish both the source and also the set of documentations and samples and other things. And there's a ton of interesting samples that we provide, and sort of downloads for ASP.NET integration. And not only that, we actually have an interesting doc if you care about the compatibility, what are the differences between IronPython versus CPython, and on and on and on. I strongly recommend checking that out, and then going from there. We also have a user mailing list that I recommend that you subscribe to if you care about IronPython or you care to use it. And I have all these links at the final slide that you can check out as well. So let's talk about the roadmap for IronPython. The first time we released IronPython is in 1.0 shape in actually in September 2006. And from there, we've been pretty regular in our updates. And one of the mantras in our team is that we cannot go for too long, about a month or a month plus, without doing release externally. And each release that we do externally will fix at least 50% of the customer reported bugs on our website. All of our bugs are publicly visible. You can actually take a look at them on our website, and you can vote for them. And whatever the users vote for are the ones that we fix, and the top ones are the ones that we fix. So we actually are converging with every release into what users actually care about in a pretty big way. And Michael gives us a lot of hard time in pointing out various different issues as he builds lots of big apps with IronPython as a whole. So 1.1 is the one that we released in April. It still uses the old runtime for IronPython runtime. But starting with IronPython 2.0, there's a big change in the underlying DLR, dynamic language runtime, that we're targeting as a whole. So starting with 2.0 and beyond targets DLR. And from a language perspective, of course, it's a 2.5 language. We're headed towards Python 3000, in other words, aka Python 3.0. And that's a little bit in flux, but I think it's starting to settle down a little bit as well. And each and every release, we fix a lot of issues with respect to compatibility that our users report back, and make sure that, that we're highly compatible there where we can be. And sometimes there are cases where we cannot be because there's some platform-specific tests that happen on that. So that's our roadmap. Any questions on IronPython roadmap? Anything like that? Feel free to ask short questions as I go through it. And what you can do is, if it becomes too long a discussion, I can take it at the end. All right, so IronPython 1.1, small release. It's just a summary of the release. I'm not going to read through each bullet here. The key point here is that it's the release that we have at what we call internally RTM, or release to manufacturing, release quality. That's what we have is release quality. The 2.0 releases right now are in alpha state, but nevertheless quite stable, quite compatible, in some ways more compatible with our compatibility fixes than the 1.0 releases, but they're still in alpha, still going through further testing. And if you run into any issues, please let us know. And I talked a little bit about sort of the language as a whole, and in the roadmap, I'm not going to cover that again, but our libraries, any Python-based library should just work, and if not, effectively, we probably have a bug that we need to fix. And if you have a C-based library from other environments, then it probably will need a porting job as a whole. From the community side, I covered the fact that we are a PSF member, Python Software Foundation member, and not only that, we actively have user groups that take our implementation and based off of the implementation do other releases such as FEPY and others as well. So how many of you here actually care about the Linux side of it? If not, I'm actually going to skip the slide. One user, two users, okay? So we have what we call FEPY released by Seiyou, who's taken IronPython and actually there's some bugs in Mono that got fixed as a result in getting IronPython to work, and he got it up and running. Not only that, he actually went ahead and sort of packaged up a bunch of commonly used libraries and then redisting that. So since there's not too many people, I'm just not gonna cover too much of this slide. If you care about the sort of the open source / the Linux aspect of it, I'm happy to sort of talk to you offline on this, but we do have our community members pretty regularly testing on other environments and succeeding as well. So let me get to some of the benchmarks and other games, right? So Python as a whole has been improving in performance, right? Here I'm showing you PyStone benchmark, and which is effectively Drystone standard perf benchmark implemented in Python, which is used to test various different Python implementations. And Python as a whole has been improving pretty well. Okay, where does IronPython stand relative to standard CPython? So IronPython, the 0.1 release, when Jim Huguenin, our architect, first implemented a version of it, in fact, he implemented in Python, targeting .NET, it turns out that it completely sort of was way faster than implementations that are out there as a whole. I'll talk about why that is the case. And from then on, we moved on to sort of implementing IronPython in C#. And then, of course, in the IronPython 2.0 Alpha 1 release, we're at Alpha 5 right now. And pretty soon we'll be releasing another Alpha 6 release in the next week or two. And we're actually at least 70 to 80% faster than other implementations out there. Well, why is that the case, right? Why is it that IronPython on .NET, in fact, is faster? So there's a little story that I will tell here for those of you who don't know. The reason we actually got Jim to come to the company because he first implemented that 0.1, IronPython 0.1 release to try to prove the fact that .NET really sucks for dynamic languages, right? He did a quick little implementation and said, holy cow, okay, it really doesn't suck, because he implemented Python in other environments before, such as Jython on top of JVM. So he wanted to test out and see what .NET looks like. And it turned out that even in the trivial implementation, it was faster than CPython implementations out there. So he got pretty intrigued, so he started spending more time and started implementing it in C# and continuing improving the perf out there. And he finally, of course, joined Microsoft, which is goodness, because we love having him in the team, and he's the key architect for now for DLR as a whole. And we continue to improve the perf, not only in every release, but as every .NET release goes out, we just ride the wave of .NET itself improving the performance. If you think about .NET Platform compared to JVM, there's several elements of it that are better than the VMs out there, right? If you think about the notion of delegates, right? Delegates, for those of you, most of your .NET users, right? Effectively typed function pointers. Delegates and lightweight code gen, the notion of reclaimable code that you can generate at runtime, and on and on and on. Those provide significant performance advantages on the .NET Platform for dynamic languages that you don't otherwise get in other environments. And not only that, our GC on the .NET GC is one of the fastest GCs out there. So combined with all that effect is what you see on the right-hand side is a great Python implementation on it. With that said, clearly your mileage will vary. I'm happy to sort of see if you find any bugs. I mean, there'll always be some corner case, right? I remember in the early ASP.NET days, people would write these one-liners in ASP.NET and compare it to ASP, because ASP is late bound and interpreted. So it turns out to be actually, if you have these one-liners, hello world, ASP is actually faster than ASP.NET. So, but if you start writing real stuff with it, so there's always these corner cases where things are faster, but for most part, we expect IronPython to be one of the faster implementations out there. Okay. So what does Visual Studio support for IronPython look like? I'm going to show you some bitmaps, then I'm going to show you a really quick demo, and I'm going to move on to other demos because I'm actually, yeah, I'm coming down on time. Okay, maybe I don't have time for Visual Studio demos. All right, so let's see. So VS support for IronPython comes through VS SDK. When you have Orcus or Visual Studio 2005, Visual Studio installed, you do not get IronPython installed by default. We explicitly chose to be asynchronous in our releases and release mechanism compared to Visual Studio cycles, primarily because we're a small agile team. If you looked at our roadmap, our timing between releases is not that long, and we're pretty agile in the way we do things. But nevertheless, you can get Visual Studio support by installing the VS SDK and building the sample for IronPython support in there. What do you get when you do that? You get editor, you get color coding, you get the project system support, and the project system support has support for both Windows Forms and WPF, and not only that, it has ASP.NET support as well. I'll demo the ASP.NET support tomorrow in my 3:45 p.m. talk, and clearly you get the debugger, okay? And then the nice part is that the designers themselves emit IronPython. And of course, the WPF designer doesn't exist in the previous Visual Studio versions, so clearly it's on the Visual Studio 2008 and above. If you're interested in looking at the IronPython support, look at Aaron Martin's blog. He's actually a really good dev on the VS SDK team who's done a lot of blogging about the Visual Studio support for this. I typically point people at his blog because it's one of the best documentations out there. So here's sort of this entire, so let me back up for a second. So what you see here is the notion of getting IntelliSense on the static libraries that you're referencing in the environment. You get color coding, you get IntelliSense on the static libraries itself, and you get a little bit of IntelliSense even for those elements that you actually have knowledge about by the time you type them in. And I don't have time to sort of delve into that, but I'll offline I'll try to show you if you have any questions there. So in addition to that, you can set a breakpoint, you get a full call stack, and this is actually pretty powerful because if you're writing large enough programs in IronPython, at some point the print style debugging that you have in open source environments won't work for you. You want a real debugger, you want to see the variables, you want to see the call stacks, and on and on and on. Not only that, the VS SDK team has done this interesting implementation of embedding an IronPython console in Visual Studio itself. So you get a much richer console support in Visual Studio, and you can get IntelliSense as you use the system libraries or any .NET libraries as a whole, which is, I think, is pretty powerful. Okay, so should I switch now? I'll actually talk about XNA, and I'll do a really quick demos of this. I don't have time to demo Visual Studio. Okay, so the next two demos really quickly that I want to be able to do is XNA, really quick game I want to show you, written in IronPython, right? XNA is a framework. How many of you know XNA? A little bit, right? XNA is a framework that allows you to write .NET apps. In other words, the .NET framework that allows you to write sort of games targeting Xbox, okay? So what does that look like in IronPython? My computer hasn't slept. Should be pretty good. Oh. Aha, good. So let's see what it looks like, okay? Oh. So I want to walk you through the code first, and then I'm actually going to go ahead and say, so what I'm going to bring up here is just basically this IronPython game that's really a pretty lame game that doesn't really do much. Let me just run it and show you what it does. Okay. So all it is just basically this little spaceship in the context of that, which is one of the sample games that comes as a C#. It helps if I turn my Xbox controller on. And then, of course, you can fly this thing around, and which is pretty interesting. What Jim did is that he's decided, actually, this is not interesting. So what he wanted to really be able to do, right, is actually add some asteroids that fly by the spaceship. So again, a very similar pattern. You add some references and you import a bunch of top-level namespaces into your environment, and from there, I'm actually going to go bottom up. Is what it does, and I'm actually only going to cover the delta because the sample is available externally on our blog if you want. What I wanted to do is just add a bunch of asteroids flying by, and in the asteroid field, I'm just going to scroll up a little bit. Right, here's the class asteroid. Right, you have these asteroids that have this like different sort of XYZ sort of positions for flying in different directions with velocities and things like that as well. So let's see what that looks like. Right, oops. So I'm going to cross my fingers now. Right, there it is. That's the asteroid field. That's about 30, 40 lines of Python code. And then you can still, like, of course, this doesn't fire yet. Ideally, you can hopefully fire it. Asteroids, we're trying to improve the game there. But it's available if you want to take it and make it fire and stuff like that. So there it is in about not that much code. You're able to, in about this much code in Python, right? You're able to sort of add some interesting effects using XNA. Using XNA as the underlying .NET framework in creating some interesting games that do things like this, okay? So this is one of the quick things that I wanted to demo to show you the kinds of apps that you can build. But there is a caveat in the sense that XNA itself runs on the desktop just fine, right? I mean, using Python. But on 360, it uses Compact Framework. And Compact Framework does not yet support reflection emit or lightweight code gen that enables you to run dynamic languages, unfortunately. So even if you write a game, you can run it on your desktop. If you write a game in Python, you can run it on your desktop, but you cannot yet run it in the Compact framework on top of 360. But we're working on that. We're trying to get that fixed. Okay, so so that's one of the quick demos, and sort of let me see if I can switch back to the slides and cover some of the other elements there. So this is the caveat that I covered. The next thing that I want to be able to quickly show you, and this is the part that I really love because my undergraduate is in actually electrical engineering, and I've done sort of a bunch of control systems work, so I love sort of poking around robots and doing robotics and stuff like that. So a while ago, Bill G wrote this article in Scientific American that talked about this notion of robots and robotics being in this domain of this enthusiast, but not really in the masses chat. And to him, that reminded of the market of PCs circa 1970s, right? Whereby PCs were like in the hands of only hobbyists. And really what got PCs to the mainstream, if you really think about it, is software. Is that how do you sort of create software for the PCs in interesting, useful, and simple ways such that you can actually go ahead and sort of do some interesting things with it. And who you see there is Tandy Trover, is the GM for Robotics Group. He's a pretty cool guy. He's got a bunch of robots there. There's the iRobot series. There's the Lego NXT. And I have the Lego NXT tripod. So I'm going to go ahead and sort of bring this up. And this is when I cross my fingers because I will be speaking through Bluetooth to my robot, which is always a fun thing. So let me actually go ahead and close this. I don't need to. So what I'm going to bring up here is I'm actually going to bring up Microsoft Robotics Studios, okay, and bring up their console because it actually sets up some environment that's interesting. And they ship I'm actually going to run their samples. They ship IronPython as part of their stuff, okay? I'm actually going to turn this on, and hopefully it has enough battery there, okay? So this is a Python sample, and again, it imports a CLR and system, and then adds a bunch of references to CCR stands for Common Concurrency Runtime, which is a robotics set of libraries, plus more, that the robotics team has built. And what this does is, let me actually run it, is Okay. What this does is actually it brings up a WinForms application. Ah, it beeped. The beep means it connected through Bluetooth. Yes, I was waiting for that beep. Now I can take this robot away, and I'll show you that in a minute. Right? So what this does is actually, let me put this side by side. It brings up a WinForms app that says, hey, when I click this left, right, go, or back buttons, just give different power to the wheels, right? When I say go, give power to both wheels. This has got 2 motors, and it's got 2 wheels right there, right? And if I say stop, just don't give any power, right? And of course, conversely, left and right. And if I have back, here's what happens there, okay? So let's see if this thing runs. And I'm going to put this over here on the floor. And this is all completely written in Python. And you can go poke around with it. You can also drive it from the interactive interpreter. And I like that. So I'm actually going to sort of go play with this, show you that a little bit, and then invite Michael onto the stage on it. So I'll just say, there it is. I can't see it. All right. So maybe I'll put it somewhere where I can say, oh, there it is. OK, great. So for those of you who can't see it, it's like right in the front. Let me see. Stop. Can't see you. And do you mind actually putting it somewhere over there, and so that more people can see it? Thank you. Yeah, you're further out. OK, now I'm testing my Bluetooth range and see. I'm just going to play with this a little bit more. Michael, meanwhile, if you want to come up and get set up for your demo, that'd be fine. So you can go like do all kinds of interesting things with it, right? And all of this is, of course, done in Python. And the whole thing is completely in Python. And let me actually go. And it keeps on roaming around on the floor there. And that's what you see. That's really what you have, this entire notion of simple, fun, little bit of code. There's not much, about 100 lines of code that enables you to use some .NET libraries and just go play around and poke around with these robots. And if you wanted to, you can interactively play with it and get some algorithms together. There's some interesting robots, by the way, that they're making, including the iRobot series, where it has a bunch of pens, so you can actually do design patterns and on and on and on. So you can actually mix the colors and do some patterns and stuff like that. So that's basically it. I'm surprised my Bluetooth is going all the way through to there. I'm going to stop it. Stop before you hit audience. So that's basically it. And I want to next introduce Michael Ford, because I'm actually running a little bit behind in time. As one of the customer examples that we have several customers that are using IronPython today that are succeeding. And I'm not going to talk through each and every element in there. The interesting one of the interesting ones is actually also MySpace, who's using IronPython as a scripting environment to sort of dispatch this IronPython code to their server farm of about 2,500, because they have Python expertise in their group, and they really want to sort of be able to use this on their Windows servers as a whole, and on and on. But I actually think Resolver is one of the coolest things that's happening. Let me introduce Michael Ford, who actually has also written a book, IronPython in Action, if you like about it. Thank you.
Okay, hello everyone. My name is Michael Ford. I've been a Python developer for about 5 years, and for the last 18 months I've been developing with IronPython for Resolver. I'm also writing a book, IronPython in Action. You can see the URL up on the screen there. The first 6 chapters are available via the Manning Early Access program, and it's a fantastic book. Highly recommend it to you all. Okay, before I show you Resolver, I'll just tell you a little bit about how Resolver came into being and why it's written in IronPython. Resolver was founded by 3 guys who work in the London financial services industry with investment banks and hedge funds. And they would see a very common situation where people had to implement a business application. These are not programmers, but what you might call power users. And they wouldn't be able to go to their IT department and say, write me this business application, here are the business rules I need to implement, because they were typically targeting a very short-term investment opportunity, maybe even individual trades or specific trades with derivatives or whatever. And so they'd do what pretty much everyone does, and they'd use Excel. Now, the Resolver founders, they felt that beyond a certain level of complexity, the traditional spreadsheet model, where you have your data and your formulae in the grid, and then you have a macro programming language sort of off to the side, if you like, that breaks down. And so they had this vision for a spreadsheet where you'd combine the power of a programming model with the data visualization in the grid into a single tool, into a single user interface, and more specifically, that the data and the formulae that you enter into the grid would actually be turned into code in an interpreted language that would be executed to produce the results of the spreadsheet, and that the user can actually insert their own code at various points into the flow of the spreadsheets, and not as a separate thing. So this is Resolver we've got up on the screen here. Let me bring up a fresh interface. This is running like the other demos on a very slow laptop. Here we go. Right, so you can see the top of Resolver is pretty much a straightforward spreadsheet. You've got the grid, the cells, rows and columns, user interface options. Down at the bottom, we've got the tabs for the three worksheets we've got in this spreadsheet. It's down in the bottom part where Resolver starts to get different, and this is the code interface. And what we'll see, what we've got here, we've got the first section of generated code. This is the import statements, and this imports all of the objects and the names that we're going to use in your average spreadsheet. We import some stuff from the .NET libraries. Within a Resolver spreadsheet, you can import anything from the .NET framework. One of the advantages of being built on top of the .NET platform, you can use that straightforwardly. And we're also importing our spreadsheet objects. We've got buttons that we can assign callbacks to. The cell range is one of the core classes. We've got our spreadsheet functions down here. And at the bottom here, we've got where we instantiate our workbook class. Now, that's the workbook is the core class in Resolver, represents the spreadsheet and contains the worksheets. Following that, we've got the worksheet creation code. This is all generated code. It's not editable. But you can see there's one line of code for each of the worksheets we've got here. So if we go and just change the name of one of the worksheets, you'll see that the corresponding change in the generated code below. Following this, we've got the first section of user code, where typically you might import Python classes, modules, functions, or .NET stuff that you're going to use within your spreadsheets. And then we've got an interesting section containing a constants and formatting dictionary. Now we've got an empty spreadsheet, so they're empty here. Let's see what happens if we enter some data into the spreadsheet. Oh, sorry, when I was introducing Resolver, I didn't explain actually why IronPython was chosen. In November 2005, the two programmers actually started to write Resolver, and they'd chosen .NET and Windows Forms for the user interface. And if you're going to write a Windows desktop application using .NET, you write it in C#, right? That's just what you do. But having this interpreted language embedded into Resolver, the generated code here, was always a core part of Resolver. So they started to evaluate the .NET scripting languages, the .NET scripting language engines that were available at the time. And they came across IronPython, and it was in version 0.7, I think, at the time. This was well before the 1.0 betas. And they started to play with it. And what they actually found was that they were extremely impressed with the .NET integration, and they found that everything that they wanted to do for Resolver, they could do through IronPython. And even more than that, they wanted to create a well-tested application. They were going to do it through the test-driven development methodology. And dynamic languages, and Python in particular, are particularly easy to test. And so we come 2 years later. We've got an application. There's 30,000 lines of IronPython code in production in Resolver. There's over 100,000 lines of IronPython in our test framework. Resolver is now in the hands of about 100 private beta users, and a handful of customers in a few hedge funds, I think, are already using Resolver, and we're going to go out to a public beta in the next 2 or 3 weeks. So if you're interested in having a play with Resolver and see for yourself, you can go to our website, resolversystems.com, you can sign up for the beta, and you can get hold of Resolver yourself. When I joined Resolver, I was actually the first developer with any Python experience there. And I've been very impressed with IronPython. Particularly, I found it a very faithful implementation of Python. It really felt like I was just programming Python, but I've got all these new libraries and new classes that I can play with and learn about. Okay, so we're going to enter some data into the Resolver interface. And you can see, coming up below in the generated code, the corresponding entries for the data I've entered. We can also apply formatting. We'll just make this bold here. And the formatting, it's the same happens with the formatting dictionary. Okay, so that's how constants are represented in a Resolver spreadsheet. An interesting implication of this is that this code that we've been looking at completely represents the spreadsheets. So you can actually save that off as a Python file, as an IronPython file, and then you've got a spreadsheet with all your business rules implemented that you can export as a .NET application. You can use our library classes, and you can then integrate that with other IT systems. So you can get businessmen implementing business rules in a spreadsheet and then integrate that into an alternative IT environment. Let's have a look at how formulae are represented in Resolver. So we've got a pretty straightforward formula there. We're summing over a range. The formula language in Resolver is a combination of a traditional spreadsheet formula language, but also Python expressions. So pretty much anything that's valid as a Python expression, we can use in Resolver formulae. Things like the list comprehensions that Mahesh showed you earlier, they turn out to be really useful and flexible in a spreadsheet environment. So we hit enter, we get the right answer, which is always reassuring. And we can go down and see how that's represented in the generated code. On the left-hand side here, we've got an assignment. We're assigning to the value of the A4 cell. And what we've done is we've generated a call to our sum spreadsheet function that's summing over a cell range. Cell range is one of the core classes in Resolver. And we're summing from cell A1, and you can see to cell A2 on the other side. Nice and straightforward. But one of the great things about Resolver is not just what you can do with a formulae, but you can actually put your own code into the spreadsheet. So let's have a look with an example that defines a function. Let's suppose we got a bunch of prices on the left here, and we want to add VAT to those. In England, the VAT rate is 17.5%. Now, obviously, if I click away at this point, that's a syntax error. You can see down in this output pane at the bottom that we haven't used so far, you can see that we get a traceback. If you're a Python user, that'll be a familiar Python traceback, which is very useful for debugging. And we can also insert, seeing as I don't really know what I'm doing at this stage, let's put some print statements in. Okay, and we've now defined a function that we can use straight within our formulae. And hopefully that's going to give us the right answer, yes. The demo gods are smiling on me. Okay, so that's nice and straightforward. We've defined a function and we've used it within formulae. But really what we've got here is we've got a 3-line function to do something really trivial. So let's do something a little bit more interesting. We can define that as a Python lambda function. You saw those briefly that Mahesh was using. Now, if you know Python, you'll see that in order to disambiguate the grammar of our formula language, we use a little arrow here instead of a colon, but it's still very readable. And we can turn that function into a 1-line lambda. And you see what's actually stored in the grid there. The cell is actually containing the lambda function. You can put any object you want into the grid. You can hold any object, whether they're .NET objects or Python objects. And this means that we can change this formula we use over here, and instead of calling the withVat function, we can actually call the object contained in cell D2 with the value that's held in A5. Ah, what did I do wrong? Let's have a look. E2, thank you very much. A6. I'm not doing very well, am I? Thank you very much. Hey. Okay, it does actually work. Right, and you can see at the bottom here the printouts have appeared in the output pane. Again, very useful for debugging. Now, those in column B, if we're displaying prices, they really ought to only be formatted to 2 decimal places. You've got the usual user interface options for doing that, but just to show how we've got access to the resolver object model from code, let's set that from some code. So this is how I get a reference to the worksheet. If I was doing this a lot, I'd probably keep a reference to that as a variable around. Now, worksheets, they have a columns indexer, cols, and we can either index that with a column number, or more commonly for columns, we can use the letter B, and we want to set the decimal places to 2. Press F9 to recalculate, and you see the change reflected in the grid. Okay, I've got another very little demo, and I was asking Mahesh whether I should show them something useful. You can do all sorts of practical things with Resolver, like take data in from databases, build user interfaces for your applications, or I can show you something geeky. And he said go with the geeky option. So I've got a spreadsheet here. This is actually an example that's on my Resolver Hacks website, resolverhacks.net. There's all sorts of developer examples there. And here we've got, if you look in the code, what we're doing is we're using complex numbers. This is a Python complex number here. We're actually calculating a circle, and we're importing from the Python standard library, and again importing from .NET there to build up a circle. I think I'm getting the signs that we're out of time.
Yeah, we're starting to wrap up, and I want to thank Michael quite a bit. This is really cool stuff. Resolver to me is like an element of sort of taking IronPython and .NET and sort of really integrating that in very interesting ways. And I'd strongly recommend checking that out as well if you get a chance. And really, my summary is pretty simple. We have a really good journey ahead of us in terms of dynamic languages. You've seen only one small slice of it, IronPython in particular, and its manifestation in various different programming elements. Really, I'm mostly focused on the client side today. Tomorrow, I'll do server side and Silverlight, and some interesting apps from customer side that we're able to build as well. So with that, I want to close my talk. And if you have any questions, please let me know. Thank you. Please fill out the eval. Thank you.